Okay, we continue our with the first chapter, which is the overview of programming language. So first thing, you will be exposed to what is programming. Okay, first let's define a computer. Okay, a computer is a programmable electronic device that can be store, retrieve, and process data. And what is programming is our behavior, much of our behavior in characterized by logical sequence. Okay, I give you example is turning a page by hand. Okay, so the sequence is you have to lift your hand, move the page from right side of the book, left top right corner of the page, and move hand from right to left until the page is positioned and go to the page. Okay, this is like a program. Okay, but this one is okay. This one is human program. Basically, program is just a logical sequence, the step by step. Okay. Just let you know that chapter 1 is mostly theoretical. Okay. So we continue. What is programming? Okay, making things done by done is a certain order of sequence. Okay, this one also example. Okay, solving mathematical problem is also a sequence. Okay, describe order and sequence of operation in a process is also called a program. Okay, so this is all program, but how about the computer program? Okay, computer program, it is a list of sequence or step the computer perform to solve a problem. Okay, the same thing, but computer done the processing. Okay, the process is described or writing this step is called programming. Okay, programming is, I think most of you know what is programming. Okay, and the list itself is called computer program. This is just a basic. Okay, computer is not intelligent. Okay, it cannot analyze the problem and come up with a solution. So you have to analyze the problem yourself, develop a sequence of the instruction to solve the problem, and describe it to computer. So basically, the programmer do that. Okay, you take a problem. Okay, you find out how to analyze the solution, to how to produce the solution, and you tell the computer how to solve the problem. Okay, using computer has many advantage. So you can solve the problem much more quicker. Okay, can perform consistently again and again. So you can process the step frequently. Okay, if you use human, they can get boring and they can make mistake. So if you use computer, it's much more consistent. Okay, and also free people from repetitive or boring tasks. That's why we use computer to solve the problem. Okay, next is the programming development. Okay, the second part of this slide is the programming development. Okay, first thing you need to do, there are 3 steps. The first step is problem solving phase. So you need to analyze the specific problem. Okay, find the general solution, also known as algorithm. Okay, the solution, the step by step is known as algorithm, and then you have to verify whether the step taken is correct or not. And then the second phase of program development is the implementation phase. Okay, concentrate the solution. Okay, means that you transfer the algorithm you have developed into a program language, and then you have to test the program whether it can get a correct result or not. And the last phase is the maintaining phase. Okay, whether it can be used, and you have to modify if there is some correction or change of requirement. So in programming, okay, how in developing program, you need to know there are 3 phases. Okay, 1, A, B, and C. Okay. So we move on to the next part. What is algorithm? Okay. Algorithm is basically programming. Okay. Programming process. Okay, begin in the first analysis of the program. and develop general solution. Okay, basically you have a program, you have a problem, you have to analyze the problem, and then you come out with a step, and the step is called the general solution. Okay, and this general solution is called algorithm. Okay. Okay, computer program and algorithm look similar because all program are algorithm. Okay. So program usually, okay. So recap, a program is a simple algorithm that has been written in a computer. Okay. So basically, you program and algorithm is the same thing, but program is has been implemented into the computer. Okay, and algorithm is a verbal or written description of the logical sequence. Okay, like I said before, algorithm usually we understand the step by step or written or verbal. Okay, so we can understand algorithm. Okay, it can be easily understand, but program are usually in the computer language, so it is harder to understand. Okay, here are some example of the algorithm. Okay, how to start a car. Okay, the algorithm, insert a key, press a brake pedal, and you know the step. So this is called a algorithm. Okay, this step is called algorithm. Okay, this one is also example of another algorithm. Okay, how to make a peanut butter and jelly sandwich. Okay, the algorithm is you put the bread, peanut butter, and jelly knife into a plate. Okay, place to slide of two bread into the plate. This step is called algorithm. Okay, this is another example of algorithm ATM machine. Okay, so you have to insert the bank card, enter the password, and so on. So all of this is algorithm. So what is algorithm? Can you figure out other previous example? Okay, and make sure that algorithm is ordered set of ambiguous executable step and define terminating process. Okay, when it comes to algorithm, you need to order it. Okay, make sure it is in order. Unambiguous means that there is no other meaning, there is no double meaning of the step. Okay, and the step can be run. Okay, execute, and also you need to have the ending. Okay, when you create a algorithm, you need to have the terminating process. Okay. Okay, this is also the characteristic of algorithm. Like I said before, okay, should be precise and ambiguous. Okay, make sure that your algorithm doesn't have double meaning. Okay, the program doesn't have double meaning, and then algorithm should have finite number of steps. Okay, means that you need to know that the step has the ending. You cannot just let the program run forever. Okay, and algorithm should produce correct result. Okay, this one is the second phase. Basically, after you run the program, you have to make sure that the algorithm produce the correct result. Okay, and algorithm should not use in particular program language. Okay, so algorithm and programming is a little bit different. Okay, it's the same, but for algorithm you can use for any programming language. For program is already goes into the programming language. Okay, programming language program is already goes for one programming language. Okay, this is also another example of the algorithm. Okay, the step taken to make the origami. So how do you describe an algorithm? Okay, the first one is by using a figure diagram. Okay, you can see here, you can use the figure to describe this algorithm. Okay, this is one way to describe the algorithm. Okay, by using a step-by-step diagram. Okay, next you can use a flowchart. Okay, so how to do flowchart is basically you have to have a start here. Okay, you have the start. Wait. Okay, this is or yes, and then burn out lamp, yes, replace, okay, no, repair the lamp. Okay, so this is a flowchart. If you never see a flowchart, this is how to show a algorithm in the form of flowchart. Okay, this one is much more you usually see a step instruction list of instruction or step, just a list. Okay, this one usually you see this in many things. Okay, so they just list the instruction or step to describe an algorithm. And lastly, the pseudocode. Okay, basically pseudocode is just a simple code. Okay, this code is not a end product of the program. Okay, this is just like a draft of a program. That's why it's called pseudo. Okay, it's not a real code. The real code is the code at the end of the, and you want to implement the program. Okay, that one can work, but pseudocode is just a draft of the code. So this one is also another way to describe an algorithm. Okay, we move on to the next part, aspect of computer and the operation. Okay, a computer typically has memory, processing unit, input and output. Okay, memory, you know, this is RAM, flash drive. Okay, this one is basic. I think many of you know this. Processing unit is the execute or run the program and produce the result. Okay, input output, of course, keyboard, mouse, printer, screen. This one is input or output. So you need to know that computer and aspect of computers. So you have memory, processing, input and output. Okay, this one is just a theory. Okay, just a general theory. Next part is the programming language. So what is a programming language? Is basically a programming a simplified form of English with math symbol that adhere to strict set of grammatical rules. So language basically like English, Malay, French, German, something like this. Okay, this one is a natural language, so human can understand it. High level language is like it's basically a programming language like a C++, Java, Visual Basic. So this language is basically the computer can understand, but it is in the form somewhere near to the natural language. Okay, this is called a high level language. Okay, low level language usually are more complex. Okay, so this one is usually harder to understand because this is assembly language. Okay, so this one is much more near to the English. Okay, much more near to the natural language. This one is much more near to the machine language, and machine code is basically zeros and one. So basically is this one you cannot understand. Okay, this one is just 0 and 1. Only machine can understand. So basically we have a assembly program to change this. Okay, this one you usually change from natural language. Okay, from your list, from flowchart or something, from the figure. Okay, figure chart. Okay, change it to high level language. Okay, this one. Okay, from high level language we can usually change it to the low level language or directly goes to the machine code. Okay, usually the process goes from you program this from natural to high, or sometimes you can program it in low level language. Okay, sometimes we can use this directly, or you can use this directly, and then from high level, you sometimes the program change to low level or directly to machine code. Okay, and machine code will be used by the computer. So make sure you know what is natural language, high level language, low level language, and machine code. Okay, next is the scientific programming language. It's a program language optimized for use in the mathematical formula and metric. Thus, this is more suitable to form a scientific numerical computer. So basically, this one is under here, high level language. Okay, a math problem can be performed with any program language. However, it is easier to be done in the scientific program. Okay. Example of this high level language is Matlab, Mathematica, and Fortran. So what is Matlab? Okay, Matlab is originally a simple language for metric arithmetic. Okay, can now do most of numerical scientific calculation. Very heavily used for scientific or numerical computing. Okay, have many special toolbox, but the problem with Matlab is cost is high. Okay, for Matlab, if not mistaken, it's around 2,000 ringgit for each Matlab license. It's quite expensive. Okay. Buy the Matlab version, you can use the free version available, okay, such as Octave and Scilab. But this one is not too complete, okay, not have many toolbox like Matlab. Okay, and the benefit of using Matlab is easier than other language, easy to do coding. So before I forget, make sure that you download Matlab. Make sure you have Matlab. Okay, if you want to find the Matlab license, you can email, I forget the name, but you can look at the e-learning. I put the way the step how to get the free Matlab from UTM. Okay, and this is a trial version. It's not a full version, but if you you cannot find a Matlab, okay, you can use Octave or Scilab. Okay, this one also almost similar to Matlab, but this one is not very powerful like Matlab. Okay, make sure you download it. Okay, before we start the next class. Another programming language that available is Python. Okay, Python is a very simple, high-level interpret language, much easier and better engineered than most. Is trap most of the error, including numerical one. Okay, best of script system interface. Okay, if you want to use Python language, you can use this program. It's called NumPy. Okay, and benefit is almost similar to Matlab. It is easy. But if you're not doing numerical computering, it is better to use Python. Okay, another programming you can use is the C++. Okay. Originally for C programmers to a high level, okay, designed for functionality more than the error prevention. Okay, this program can run whether it is error or not. So that one is not very good for C++. Not really a good or for scientific programming. Language is very good. Okay, needs a lot of third-party library. So if you use C++, you need to include library. That's why at the top of the C++, you can see that open bracket include library. What library? So this one is, I don't recommend using C++. But the best thing about C++ is it is fast, high efficient, and can create own data structure. Okay, another program that you can use is the Fortran or formula translation. This one is simpler than C++, comparable power with C++, and this one is very old program. And this one easy to code in parallel. If you have program run together, it is much more better if you use Fortran. This one is also portable, high efficiency, and support for metrics. So this is the comparison. Okay, for easy to use, of course, Python and Matlab are usually easier than Fortran. Prototyping in Matlab is much more better. Prototyping means that how you want to start doing a program. So better to start with Matlab. Debuggability means that it is easy to debug Python and Matlab are easy to debug, to detect what is a problem with the program. Fortran is quite difficult. For performance, of course, Fortran and C++ is much more faster compared to Python and Matlab. And parallel programming, you cannot do with any other language, but Fortran you can do parallel programming. Okay, array handling and text handling. Array means that number. Okay, number handling. Okay, Fortran, Matlab, and Python are very good. Okay, text handling means that if you have text, it is much more easy to process. Matlab is not very good in processing text. Okay, and computer science, if you want to do computer science, better to use this. And lastly is the system interface. Okay, I think they forget the Matlab. Okay, so this is just an overview of 4 different programming language. So understand so far? Any question before I proceed with the next part? Is the basic of programming.
No.
Okay. So we take 5-minute break, and we will continue with the basic programming sequence.
Doctor, we can't hear you.
Sorry, I forget to unmute. Okay, I will step back. Okay, the first thing you need to know about basic of programming is the sequence. Okay, so sequence means that the program is just directly. You have a statement here, a statement here, a statement here. It's just direct path. Okay, you only have a direct path. This is just a sequence programming. So you have step 1, step 2, step 3. Okay, this is direct sequence. Okay. Okay, next basic of programming is the selection. This one happen when you have a condition. Okay, true or false. You have to set a condition. You need to know whether it is true or false. Then you can select the statement. If true, what happened? If false, what happened? This is basically a branch of decision. Usually you can use if, then, or else. Okay, these statements are usually available in the programming language. Next is loop. Okay, you have a condition here. Okay, then you run a statement. Okay, and then you check again the condition and whether it is true or not. If true, you have to run again the statement, and if it is false, you continue with the next sequence. So basically, loops is the process you run again and again until the statement is false. Okay, this is basically a loop type programming. Okay, this one is subprogram. Okay, also known as procedure or function or subroutine. Okay, this one is basically, I give you example. If you want to go from home to office, okay, basically somewhere at this location, maybe your phone's ringing, so you run another program. Okay, it's basically a sub program. So you run a main program here. You want to go from home to office. Suddenly there is a call, so you have to run a sub program to answer the call. So this is basically a sub program. Okay. So after the sub program is complete, you will go to the main program back. Okay, so this is the basic programming. Okay, sequence, branch or decision, loop, and subprogram. That is the basic of programming. Next is the flowchart. Okay, as I mentioned before, how to show algorithm. Okay, how to show algorithm. Okay, you can use a diagram, flowchart, instruction, or pseudocode. So I will show you this flowchart. How to do a flowchart to describe algorithm. Okay. Okay. So flowchart is basically a graphical representation of a program to solve steps so that it can make a clear about the program. There are two types of flowchart. System flowchart. System flowchart given complete processing of mechanism and cannot be converted into a program. Okay, this one is organization structure of a college, for example. And program flowchart, a program flow that gives the problem solving method and can be converted into program. Okay, this one problem, calculate triangle area. Okay, for example. So system flowchart is basically something like organization. You cannot just show you the organization. Okay, that is a system flowchart. Program flowchart you use to show the step. Okay, so we focus on the program flowchart. Okay, this one you need to know what is the meaning. Okay, first thing you need to know, you need to have start. This one is process. Okay, any step you want to take, you have to use this process. Okay, if you have decision, you have to use this. Okay, decision, you have to use this one. Okay, this one if you have input and output, and this one start and finish, and this is arrow. Okay, to show your program. Okay, this one is usually show is as connector. Okay, I give you some example how to do flowchart. Which one? Oh, sorry, I cannot use my pen right now. So I just give you the slide from the slide only. Okay, some properties of good flowchart. Flowchart should have only one start and ending. Okay, remember this? This one only on all of your flowchart, you need to only have start and finish. Okay, this one, okay, this one, okay, you need to have only 2 in a flowchart. Okay, because you need to use this as start and end. Okay, so the flowchart should have 1 start and 1 ending point. Okay, so make sure that the oval one has only 2 in a flowchart. Okay, and flow line should not intersect with each other. Okay, so you cannot intersect the line. Okay, so when you do decision, make sure that you don't intersect. Okay, the flow needs to be clear. And flowchart should not contain the programming language. Okay, so flowchart should not contain any, for example, if else. Okay, that one you cannot put in the flowchart. And flowchart should be neat and clear to use. Okay, and the disadvantage of flowchart is it takes long time to prepare. Okay, it's quite hard to draw the flowchart. It's good, easy to understand, but the problem is it's quite take a lot of time to prepare. Okay, and the translation from flowchart into a program sometimes is quite difficult when compared to pseudocode. Okay, so this is an example of a flowchart. As I mentioned before, you need to have start and end. Okay, so start and end. You need to have 2 oval, start and end. Okay, this one, remember this is when you have input, you have to use this shape. Okay, parallelogram. Okay, show input and output step. So for this case, you need to have input bread, peanut butter, jelly, and knife and plate. So this is example how to make a sandwich. So put 2 slices of bread on the plate. This one is just a instruction, okay, statement or instruction. So remember, for instruction, you need to use rectangular shape. Okay, so use this. Okay, same as here. Okay, spread the butter. This one is just a step, so you use rectangle. But this one is, do you want more jelly? This one is a decision. Okay, so when it comes to decision, you need to use a diamond indicator like this. Okay, so make sure okay, if you want this one more jelly, yes, goes to the statement here. Okay, square statement. This is just a statement. If no, just statement. No, just slap 2 slices together. And you can see that the flow is not intersect. Okay, just clear clear direction. So something like this. Okay, go move here and move here. If no, just directly slap 2 slices together. So this one also another decision. You have to use a diamond shape. Do you want more? You want another? Yes. Goes back here. This one. This one is not it's not intercept. So basically, you can see here goes here, and then this arrow goes here. So this is clear. Okay. Move from here to here. Okay. You cannot have another direction here. Double way. Okay. So make sure that the arrow is clear. So if yes, you have to make again. If no, you just eat the sandwich. Okay. So this is the output. Okay. Output and input has the same shape. Parallelogram. And of course, at the end, you need to put end of the program. Each program needs to have the ending. Okay. This is one example. Okay. This is example of flowchart to get the ATM. Okay, of course you need to have a start here. Okay, get the password. This one input, you need to use this shape. Okay, make sure you know how to use the shape. This is the decision. Is the password good? Okay, if no, give response to error message. Okay, error message. Go here, go to no. And if the password good, goes to the here. Get amount, the type and amount. This one is also input. So you have to use this drawing as a input. So goes here, deposit or withdraw. Okay, this one is decision. Whether you want to deposit or withdraw, you have to use this shape because this is a decision. Okay, so this one and this one. Okay, this one is okay. If you have multiple, okay, multiple decision. Okay, this one have decision, this one have decision. You have many statement, and then after complete all of this, you need to combine all the decision. Okay, this one go back to the main program, then goes here, and of course goes here because there is no other way, right? Just goes here, just go here. So this is example of the flowchart for ATM. Next is the pseudocode. Okay, I mentioned before. Okay, this one, how to represent algorithm. Okay, diagram, flowchart we have mentioned before. Okay, we have learned. Okay, list of instruction. This one is much more direct, and then is a pseudocode. Another how to represent or describe an algorithm. Okay, so what is pseudocode? Pseudocode is a notational system in which idea can be expressed informally during algorithm development. Okay, it is just a loose representation of formal language. Okay, it is used when the target programming language is unknown. Okay, basically, okay, for example, if you want to use a Matlab, you have a very the program is written with a, like I say, a good grammar. Okay, a very good grammar, because if you use a wrong grammar in the Matlab, okay, you cannot run the program. Pseudocode is basically just a programming language that is not using a correct grammar. Okay, but it is still can be understand. It just cannot be run by the program. Okay, computer cannot understand it, but we can understand it. That is called a pseudocode. It's almost like a code, but it's not complete. It is with a wrong grammar. So you need to make sure the difference between pseudocode and code. Okay, usually we use this statement. Okay, begin, end. So start and end, you should usually begin and end. Okay, procedure. Okay, if else, this one is if you have a conditional or branch or decision. Input, output. Okay, loop, you can use while. Okay, next. Okay, usually we use while. Return if you call a subprogram. Okay, if you goes to subprogram and then you want to, after complete the task, you write return. Okay, this is just a pseudocode that usually being used in the writing of the pseudocode. Okay, this is a pseudocode example. Okay, this one is sequence, just directly perform task 1, perform task 2. Okay, but for this one is the flowchart. This one is the pseudocode. So as you can see here, flowchart is much more difficult to build. As mentioned before, it's harder to build because you have to draw one by one. Pseudocode is just perform task 1, perform task 2. Just write it. Okay, this is another example of decision making flowchart. Okay, you have to draw rhombus. Okay, you have to draw this. Okay, you have input and output. But if you use pseudocode, if max more than 0, then output. Okay, max more than 0, yes, output is positive. Then else means that no. Okay, this is no. Else means no. Output not positive. Then and if. So this is the end of the program. So for loop, okay, if you use flowchart, okay, count as 0, okay. So assume count is 0, sum is 0, sum plus count. So count equal to count plus 1. So basically, it's run, okay. You look the count. Count is still at the beginning 0, at this point is 1. So compare count whether it is 0 or not. If not, it will goes back to the summation. Okay, increase 1, 2, goes again 3, 4 until 5. 5 it will count is more than 5. So yes, it will end the program. So this is the flowchart for loop. Okay, if you remember before. Okay, this loop. Okay, programming, basic of programming. If you want to use loop. Okay, so this is how to do a flowchart. And if you use pseudocode, it's much more easy. For count equal to 0 to 5, okay, means that if count is 0 until 5, you have to sum. Sum is equal to the sum of the count. Okay, next count means that you count what is this. Okay, you count the count. Okay, you calculate the count and then end the program. Okay, this is pseudocode. So if you can see here, flowchart is tedious, a lot of things to do. Pseudocode is much more simple. Okay. So this is an exercise. Okay. Draw the flowchart here. So everybody can start drawing. Okay. Try to do this. I will call someone. Okay, I give you 5 minutes to do this. So complete it, and I will call somebody to present. Okay, complete. So I will call somebody. Okay, how about Firdaus Kamal? Can you present the flowchart? Firdaus Kamal. Can you show your result? Can you share it? Is it possible or not? Okay, we will have a tutorial session to do this. Okay, any question? I think this is the end of this chapter. Wait, first. Okay, yes. If you want to do reference, you want to find a reference, you can use this. Okay. So any question before I end the class?
Doctor, I have a question.
Okay.
Can I put the result after the start, because before the input, result
Before
equals
the
to
input.
0. Result equals to 0. Can I do that?
This one. Okay. If you look at the sequence, okay, it show the N, D, and then right. Usually you have to follow the sequence.
Okay.
For this case, it's not important actually, but because this is just a exercise, you need to follow this. But if the programming, the result is the same. Okay, because this is not depend on each other. But if you want to do the conversion, you need to follow step by step. Okay? If you do this, you can get the wrong. Your mark can be reduced. Okay. Any question?
Good morning, doctor. Can I ask
Okay.
from the pseudocode, how do I know it is well loop or do well loop?
Oh, this one. Okay.
From
You
the
want to
pseudocode.
know code. Okay. For this case, you want to know whether it is pseudocode or code. You have to wait until you. I think you cannot know whether this is pseudocode or not because you still not familiarized with the Matlab. If you
Okay,
put this
I know,
coding into the yes.
doctor. Can I know the well loop? It is well loop or do well loop? How to differentiate it from the pseudocode?
I don't have an example right now, but if you want to use okay, I open Matlab first. The easiest way to do this, you copy this code and you run in Matlab. If you copy this and you run in the Matlab, you cannot run it. It is a pseudocode because it is a code with the wrong grammar. Like I said before, pseudocode is just basically a code with a wrong grammar. You are the Matlab cannot understand it, but you can understand it. So if I copy this, okay, this is Matlab. Okay, so already problem. Okay, unrecognized something. So you cannot run this. This is pseudocode because you cannot run in Matlab, but you can understand what it means. It is just a what we call half-baked code. Okay, it's not a complete code. A code with the wrong grammar. After
Okay,
you learn
thank you.
Matlab, you can see it. Okay, welcome. Okay, another way to see is in Matlab you cannot use arrow. Cannot use arrow. This one you cannot use. Another begin is not a code. Okay. So any more question?
Oh,
Okay. And don't forget to tick your attendance. Okay. And if you want to see the video again, make sure you can look it at e-learning. Okay. If there is no more question, okay, we can end our class. And I will
okay,
see you when.
doctor.
Okay.
Thank you, doctor.
You're welcome.
Thank you, doctor.
Bye, doctor.
Thank you, doctor.
Okay, welcome.
Have a
Thank
nice
you,
day.
doctor.
Thank you, doctor.
Okay, have
Thank
a
you,
nice
doctor.
day.
Have a nice day.